Hello, ladies and gentlemen. This is Mr. Heeren. I'm trying to talk to you about Unit 2.4, kind of keeping with this whole main idea about the unit circle. So today we're going to talk a little bit about the unit circle, but then kind of add a little piece to it beyond that. Starting with conversions and coterminal angles. So the big picture idea is coterminal just means for degrees and radians, if I go around the unit circle more than once, if I keep going around and around and around and say I stop here, what's going to be the cosine, what's going to be the sine of that location. So that's kind of what we're looking at when we say coterminal. So one way to think about it would be, if I get on the merry-go-round and I go multiple times around and I stop, what's my value there? What is my what's my either angle or my radian value there? So again, then we have cosine and sine for that function as well. We'll also kind of think about the idea of a periodic function and what that means. So a periodic function is often represented this way. Don't worry, don't panic. I'm not asking you to write any equations. What this is saying is that you are looking at something that repeats over and over and over again, but then all P is representing is like a rotation. So if you think about a circle as a merry-go-round, you learn all your values going all the way around the circle. Then the second time around the circle, you're repeating those values. All right, you're repeating those different times around. So if it goes around once, twice, three times, you're just overlapping. You're just repeating those values as you go around the circle. So if I go to, we'll just call this the, pi over 4, the 45 degrees, we know that is square root of 2, square root of 2, square root of 2 over 2, square root of 2 over 2. That's from your unit circle. But what you need to be able to do is recognize that if I go around this 5 times and land here, it's still going to be the same sine and cosine. It's just a matter of how many times do I go around the circle. Periodic tables, I used it for the example of the circle just because that's kind of what we've dealt with before. But you have seen other unit circle or other periodic functions. So this would be a graph of someone humming a tune. This would be a periodic function. You'll actually get really familiar with this in Unit 3. This is another periodic function. If you look, it kind of goes along that same path and then repeats it. Those are considered periodic functions. It's a function that repeats itself, but now all you're looking at is kind of the rotations. One of the biggest periodic functions that people don't realize is time. You are repeating the same time over and over and over again. Seconds, minutes, hours, days. They all have a period where they are on the clock or the calendar. So time by itself is a periodic function. You keep going, February, 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 every year. All you're doing is adding 12 each time for 12 months. So that is a periodic time. February plus 12 gets you back to February, plus 12 gets you back to February. So it is a function of time. So let's kind of think about this and see what we're dealing with. So if I consider that the minute hand of a clock is at the very top, okay? You're considering the clock, 12, 1, 2, 3, all the way around. The minute hand, the long hand, is at 0. Okay, all those little tick marks as you go around. So where is the minute hand 152 minutes from now? So obviously 152 minutes, way bigger than an hour. Okay, 60 minutes is 1 hour. That hasn't changed. So how do I figure out where it is? Okay, so I'm going around this clock. I'm going once, twice, figure out where I end up. Now here, you can kind of what I call brute force and figure out, you can take 152 minus 60 minus 60 and get what you need and get to 32. So yeah, it's obvious it's going to be at 32-minute mark. All right, so if you did that, you wouldn't be wrong, but that gets a little tedious. Okay, so a different way, maybe a slightly more direct way and a little more clever way, would just be to take 152 divided by 60, and that's going to get you 2.53 repeating. So the 2 represents your rotations around the clock. So you go 0.53 past your 2 rotations. So all I'm going to do is take that times 60, and that's going to give me 32 minutes, which is exactly what we had here. All right. So this way would work in this case because it's not too many. You know, if I said it was 2,882 minutes, you probably wouldn't want to just keep subtracting 60 because you'd be there all day. But for this case, it would work. So where was the hand minute 85 minutes ago? Well, if I do it kind of the brute force way, 85 minutes is 1 hour and 25 minutes ago. So I'm kind of going backwards here. So on my clock, I'm still starting at 0. I'm going around once, and then I'm going back another 25 minutes. So 1 hour, then I'm going to go 60 minus 25. So I'm going to end up at the 35-minute mark. I can do it either way. It's just a matter of, you know, in this case, 85 minutes, it doesn't take much to break that up, take an hour away, take 60 minus 25 and figure out I'm going to be at the 35-minute mark. So here, if it is January, what month was it 3,002 months ago? So how are you going to do this with any amount of cleverness? So you can sit there and start subtracting 12 over and over and over again and hope you get there. That's going to take a little while. What I would do is take 3,002 and divide it by 12 because there are 12 months. So that's going to give me 250.16 repeating. So if you wanted to keep subtracting 12 here, you would have to do it 250 times. That is not a great idea. That's not a very efficient way of doing things. So 302 months ago would be, means you're kind of going backwards in time. So you're going to take this 0.16 repeating times 12, and you end up with 2. So you have to realize that you're in January, and you're going 2 months back from January. So with January, go back as December, and go back as November. So November is going to be 3,002 months ago. Okay, so what do you think this looks like here for today? Is Wednesday. What day is it? 184 days from now. Well, you can sit there with 184 and keep subtracting 7, until you get down to how many days it is, but that's a little nuts. So I would rather take 104 divided by 7, because there's 7 days in a week. And I'm going to get 26.286. Okay, so that means 184 days from now, you're going through 26 weeks. You're going through half a year plus 0.286. Okay, so I want to subtract the 26 weeks. I just want to deal with the 0.286. I want to take that times 7, and that gives me 2. So now I started on Wednesday. I add 2 days. So 184 days from now is going to be a Friday. Okay, so take a second, take a look at that and see what I did. Okay, just kind of get the idea that that's kind of how I'm manipulating. That's how I'm playing with pure functions. Okay, so what does that have to do with us? So on the unit circle, we have what is called a terminal point, and it is exactly what it sounds like. Terminal means ends. So where does your point on the unit circle end? So the measure of an angle is determined by the amount and direction and rotation from the initial side to the terminal side. So we all started here, we rotated around, so we got 225 degrees. Negative starts from the other direction and goes this way. So this would be considered your terminal sides. That's what you're looking at right there. All right. Now you have to realize that you're going to go around the circle a few times and see where you land. So what we're trying to do is consider that one rotation is 2 pi and 360. And what we're going to do from that is realize we're trying to eliminate the rotations and deal with kind of where we land within the unit circle. And here's what I mean when I say that. 30 degrees is the simplest one. So that's pi over 6. 390 degrees means I go all the way around the circle plus another 30 degrees. All right, 750. Means I'm going to go around twice, but I'm still going to end at 30 degrees. All right, so that would be 750. This would be 390. This would be 30. 1830 means go around a whole bunch. These would all be the radian equivalents of those. All right, that's going to be just your radian equivalent. So if you consider that this is 2 pi, and it will really, really help if you consider that 12 pi over 6. I don't know why I wrote 2. Don't do that. 12 pi over 6 is the equivalent. So 12 pi over 6 plus pi over 6. So that's where they get 13 pi over 6. Okay, this represents one rotation, one trip around the circle. So that is where they get 13 pi over 6. This last one, the negative factor, means this. You're starting from your 0, you're starting from this side again, but you go negative 330 degrees, means you come from the other angle. This is still 30 degrees, you just came at it from the other side. So that's kind of what you're trying to get used to, is realizing that you're going around the circle a number of times. You're trying to figure out where you're going to land. That's kind of your punchline, what you're doing. So coterminal of 29 pi over 6. So obviously you recognize that that is way bigger than 2 pi. So now we have to do a little bit of thinking. So you can sit there and go 29 pi over 6 minus 12 pi over 6 minus 12 pi over 6. You can sit there and do that. That's a little bit cumbersome. I don't love that. You can do it. What I would prefer to do is convert this to degrees and go from there. So doing that, I get 870 degrees. So 870 divided by 360 is going to be 2.416. So this is representing 2 rotations. And then I'm going to take 0.416 repeating times 360. So I get to 150 degrees. But now they want you to go back to radians. They gave you this in radians, you got to go back to radians. So remember, this is just going to be times pi over 180, which simplifies to 5 pi over 6. That's my answer. Okay? So I know it's a little bit of a long way around. I think it's a little easier to deal with. You could sit there and, depending on how good you feel, take 29 pi minus 12 pi minus 12 pi and get 5 pi and realize that that's got to be over 6. You can do that on this one because it's not very big. You're not rotating very many times. That's not always going to work. So like here, if I took 85 pi over 2, are you seriously going to sit there and, you know, the equivalent 2 pi would be 4 pi over 2. Are you going to sit there and seriously go 4 pi over 2 minus 4 pi over 2 minus 4 pi over 2 until you get down to something? Absolutely not. That's crazy. So what I would do is convert this and when doing so, you get 7,650 degrees. That's a whole lot of rotations. So divide it by 360. Gives you 21.25. All right, so 21 represents your rotations. So you're going around the circle 21 times, and then you get dizzy, and you're going plus another 0.25. So I take the 0.25 times 360, which gives me 90 degrees. So 90 degrees, that's as a degrees. I want it as a radian, so it's just going to be pi over 2. Take a minute, kind of mentally process that, and then you can go. So now how does it change when I throw a cosine or a sine in front of it? The answer is not much. You take it one step further. So remember, you go cosine of x, sine of x. So you take it one step further and you just figure out your function. That's all you do. So when I look at 19 pi over 3, so if I take that 180 over pi, that's going to give me 1140. Divide that by 360, I get 3.16 repeating. So that means I'm going around the circle 3 times. 0.16 times 360 is going to give me 60. So what they really want is the cosine of 60 degrees, which is the equivalent. It is coterminal, but it's the equivalent of 19 pi over 3, okay? So the cosine there, you can check your unit circle, should be a positive 1/2. For B, things get a little trickier because that's a really, really big number. I wouldn't even try and mess with that. I'm going right to converting it. Cancel, cancel. A little calculation, a little calculator mashing later. You get 18,585. Divide that by 360. You're looking at 51 rotations times 0.625. All right, so 51 rotations times another 0.625, so over halfway around the circle. Doing that gives me 225 degrees. So what's my sine function at 225 degrees? Remember, it's down in the bottom left quadrant. It's down in quadrant 3, so everything is negative there. But the upside is that both of them are the same, so you're looking at square root of 2 over 2. So now if I look at this, negative 52 pi. Remember, negative means I'm starting here and going this way. So here I'm going this way around the circle. So I want to multiply. When I do that, I end up with negative 1,560. Divide by 360, I end up with negative 4.3 repeating. So 0.3 repeating, 1/3 times 360 is going to give me negative 120 degrees. So I go negative 120 degrees this way. Okay, so you're down here in quadrant 3. This is like a 60-degree angle from there. Okay, so this is the equivalent of 240. All right, so this is the equivalent of 240 coming from this way. So you have to figure out your cosine there. Your cosine there is going to be negative 1/2. So for letter B, 70 pi over 4. Again, you're going negative. So you're starting here and going this way. You want to figure out kind of what the equivalent is. So negative 70 pi over 4 times 180 over pi. A lot of multiplication later. It's negative 3150. You know, the pi's cancel out. Mash your calculator a little bit. That's what you get. Divided by 360, negative 8.75. Okay, so negative 8 rotations. So 1, 2, 3, 4, 5, 6, 7, 8, plus a negative 0.75. So if I go 0.75 negative times 360, I get negative 270. Which means on my last rotation, I go 90, 180, 270. So that's negative 270, which happens to be the equivalent of positive 90 degrees. So I want the sine of positive 90 because they're coterminal, they're at the same thing. That's going to be 1. Just remember that 0, 1 up there. So that's kind of what I'm looking at to do. Oops, sorry, did not mean to do that. Cancel it out. Let's see what we got next. So keep this handy, keep this nearby. Hopefully you have a paper copy of it somewhere. So realize going positively, going negatively, and then they're going to be coterminal. Some of them are going to be coterminal. So if you find the coterminal angle, 17 pi over 3, multiply that times 180 over pi. Pi's cancel out. So you get 1020. So divide that by 360, you get 2.83. Repeating. So that means 2 rotations. But I don't care about that, so 0.83 repeating times 360 gives me 300. So you're 300 degrees, but they give it to me in radians, so I've got to go back to radians. So I need to multiply this times 180 over pi, which simplifies to 5 pi over 3. Number 2, figure out your exact value. Cosine of negative 21 pi over 4. So negative 21 pi over 4, 180 over pi. Negative 21 times, sorry, not 90, 45, duh, is going to be negative 945 divided by 360 is going to be negative 2.625. So negative 2 rotations, 0.625 times 360 equals negative 225. So that means on the unit circle, I'm going negative 90, negative 180, negative 225 is right there. So that from this direction becomes 135 degrees. So the cosine of 135 degrees, that is where that's going to be, let's see, that is going to be negative positive. So that one's going to be negative square root of 2 over 2. Okay, so can you do all these things? Let's take a look at the assignment. All right, let's say you can scratch off number 1. And then if I jump down here, let's scratch off 10, 12, and 13. So you're looking at 1, 10, 12, and 13. Don't do. Now on the back side, let's go 20, 22, 24. You can skip those 3. Okay, if you have any questions, please let me know. We can jump onto a Google Meet. Don't forget your meeting times this week, and I look forward to talking to you. Thank you very much.